Hi, welcome to R2E, and this is another video in the Kleppner series, and we are going to solve this problem. So what this problem says is that you have this pedagogical machine, and you are applying force F on the mass M1, right? So I want to determine what is the value of F such that this mass M3 out here stays in its position and doesn't fall down. So let's try out the problem. Alright, so the idea is, let's look up the motion of each component of the body. Let's look at the forces on the each mass. So let's see, let's say I have this okay, it will take some time for me to draw. So I mean, not that good, but still works. So I have this mass M1. So obviously there is a force F that is acting on it on the horizontal direction. You see, M3 is hanging in this, say, a little pit, and definitely when the block will be moving, M3 will be touching one of the walls. So M1 will be applying a force, let's say F1 prime on M3, so that M3 also moves with the block with the same acceleration A. So M3 in return, by the Newton's third law, will apply a force on the M1 block, that I say F dash, right? And you see, at this pulley junction, so there is a tension T out here, right? So there will be a net of root 2T being applied on this M1, right? But since we are looking in the horizontal direction or in the x direction only, I mean, the vertical component of it will be neglected, will not be considered. So this will be F minus of F bar minus of T, that is equals to M1A, right? So that was the equation of motion of M1. Now let's look at M3. So as I said, F dash is acting on M3, and F dash equals to M3A. As simple as that, because there is no other horizontal force acting on M3. And now about M2. So definitely there is this tension acting on it. So there is this tension acting on M2, and so it will be simple that this tension is actually equals to M2A. So all this machine is actually moving with the same acceleration. So I am keeping A, I mean A has to be same everywhere. Now let's consider the vertical motion. So I have this this, I mean, if I see this component, so there is this tension minus of M3G equals to, M3 y double dot. So this is the acceleration in the y direction, but the condition in the problem says that there is no acceleration in the vertical direction. So I can just take this thing to be 0. So that will be tension equals to M3G. So I have this mass M2 here, where from here I know that M2A is actually equals to M3G. So my acceleration will be M3 upon M2 times G, right? Now I know everything. Like I know A, I know T, I know F dash. So I can calculate F. So my F will be M1 M3 upon M2 times G plus M3. Okay, I think I should not have done this like this, but okay, M1A plus M3A plus M2A, where it will be M1 plus M2 plus M3, and A goes common, and that becomes M3 upon M2 times G. So that is simply the force acting on the body. So with this we ended the problem. See you in the next problem or the next video. Bye.